Once again, very good morning and thanks for joining. So, in continuous to yesterday's session, so today we are going to discuss again base concept about DBMS versus RDBMS and database system and modern database system futures and different types. Okay, before I straight away start the SQL Server Architecture, this is as a database administrator. We must and should know what we are learning first. So that's one of the reason we are going to first start with what is DBMS, what is RDBMS, uh, how many database models are available. Okay, then what is SQL? Then we'll start the SQL Server Architecture. So basically, the first thing that's what we are discussing: DBMS versus RDBMS, DBMS type, SQL language, and concept overview. That's what we are going to discuss today as part of the agenda. So as part of first thing, so we are going to discuss SQL Server. Now, majority of the database management system, not only SQL Server, all the database management system, majority of the database management systems, okay, will follows client server architecture. There will be client, there is a server, it follows client server architecture. I'm not getting super. See, basically, your client can be tool, your client can be a desktop, your client can be browser, anything. It can be tool, it can be desktop, it can be browser. Okay, and your database will be either SQL or Oracle or Postgres or Sybase, anything. And there will be application where they design this application client is not. They design the application with the Java, PHP, .NET, or AngularJS. So different languages they will use to design the application. So there is no middleware here for database management system. There is nothing called like a middleware. I'm not getting super basically. See, I'm not sure how many people having idea about Oracle apps. See, if you wanted to work with the Oracle apps is the ERP tool. ERP tool. Like SAP is a ERP tool. Oracle apps is a ERP tool. So when you specially go for Oracle apps, it is a 3-tier architecture. There will be a client, there will be server, okay, and you there is a middleware. Okay, means Java. They want Java. Okay, if they wanted to work with the Oracle apps, first they will install the client and they will install the server Oracle, because Oracle apps backend they will use the Oracle as a server. So they will install Oracle as a server and they will install the client, and they need Java as a middleware. So that's the reason it is technically we'll call it as a Oracle apps is a 3-tier architecture. 3-tier architecture. But SQL servers or Oracle or Postgres or MongoDB, it's a 2-tier architecture. So we are having client, so we are having server. There is nothing called middleware. So you don't need any middleware if you wanted to work as a database administrator for especially our engines. But what do you mean by client, Subbu? See, SSMS is also one client, SQL Server Management Studio. If you wanted to connect to the SQL, if you wanted to work with the SQL, so we will use one tool called SQL Server Management Studio. Like each database management system, they came up with the different tools. So for example, Oracle, they came up with the Toad, SQL Plus. For MySQL, they came up with the Workbench. For Postgres, they came up with the DBWeaver or PCAdmin4 or pSQL. So every database management system having their own tools. Every database management system having their own tools. These tools are acting like a client for us, where we can access the engine, where we can do whatever activity we can do everything from here. So this is like a client for us. Okay, so client server, there is no middleware here. But if you generally go to the Oracle apps or some ERP kind of stuff, definitely there should be a middleware. Okay, if you wanted to work with the Oracle apps, you must and should install the Java also. Java is acting like a middleware. So SQL Server will follow only client and server architecture. Your client can be designed by Client is nothing but where you are at. See, browser means not getting idea. See, if you open Amazon, www.amazon.com, so where you are going to Amazon is that application is completely designed with Java or PHP or .NET or CSS or HTML using different languages. They design that application. Whenever you are going to place an order or anything, it will prompt you to log in. It will prompt you to log in. So what information you will provide as part of the login? So your email address, your first name, your last name, your mobile number. Somewhere that information is storing, right? Next time when you are trying to log into the Amazon, you will provide your email address or mobile number and password. So somewhere it is storing. And whenever you are placing any order, okay, so you are going to place the order, you are going to track the order, you can going to cancel the order. Everything is going to store under your credentials, everything. So somewhere your data is storing. So where it is storing, that is your database management system. Okay, whatever you are doing, somewhere your data is storing. So where that is storing, either it can be SQL, it can be Oracle, it can be MySQL, it can be Postgres. That application is mapped to which database management system. So in that database management system, your data is storing. So SQL Server or Oracle or Postgres or MySQL or MongoDB will follow client server architecture. There will be client, there is a server. There is nothing called middleware. This client can be designed with Java or .NET or PHP or CSS, any language. Using that language, they design the client. It can be application, it can be browser. It can be application, it can be browser. So they will open the application, they will open the browser, and they can access our database management system to store the data, to render the data, to process the data. So there will be client, there is a database. But some of the applications will be three-tier architecture. Okay, for example, ERP is a three-tier architecture, which contains client, server, and there is a middleware. Without middleware, you can't do anything with the Oracle apps. Like, but if you go for SQL Server, nothing like a middleware. It's a two-tier architecture. There will be client, there is a server. Got it, everyone?
Yes, Subbu.
Yeah. Now, basically, this is the terminology we are hearing. Okay, DBMS, RDBMS. See, database, okay, management system, relational database management system. So before we go into the DBMS versus RDBMS, first we need to know about the database. See, database is like used to store and manage the data in a hierarchical level pattern. So easily you can access the data, easily you can manipulate the data. See, because whenever you install any database engine, okay, is our job is done? No, we will create the databases. Okay, so for example, you are going to store the accounts data in this database. You are going to store the sales data in this database. You are going to store the customer data in this database. See, so we can create multiple databases and we can store different objects of different information, and we can easily to access because these are in hierarchical, easily to access, easy to manipulate, because that is how we are segregating the data here. In this databases also, see, easily to human related data, person address related data, country related data. So see, segregation is happening internally. Will you do all this stuff, Subhumis? No. Developers. This is everything will be developer handling. As a DBA, we will maintain the databases. We are not doing anything, but even you are a DBA, you should understand that how the DBMS technology is working, how the RDBMS technology is working. Okay. In general, if someone is asking what is database is nothing but collection of data where you are going to organize it. In the organized pattern, you are going to store the data. To access, we can easily access the data. We can easily manipulate the data. You can easily access the data. You can easily manipulate the data under the database management system. Under the database management system. See, when we think about the database, we usually wants to system that could handle and maintain the data for a longer run. Okay, so where you can store your data, and ideally every database management system will handle the CRUD operations like creating, reading, updating, deleting, inserting. Okay, you will create the structure, you will load the data. Loading in the nothing but, for example, you will go to the bank and you wanted to open the account. So what you will do first, you will try to insert your record. In, First, you need to create account. Once your account is created, then you can update the information, or you can just delete your complete account from so on so bank. So delete operation, update operation, read operation, create operation, CRUD operations. Okay, so as a database administrators, so all the database administrators will fulfill the CRUD operations, basically databases, where you can create, retrieve, update, delete, along with the insert also. You need to load the data first, insert also. So database, if someone is asking database is nothing but collection of data which is organized, where we using that we can retrieve the data a little faster, we can manage the data for a longer time using our database management systems. Now, coming to DBMS versus RDBMS. Okay, DBMS stands for Database Management System, where the data is stored in a hierarchical level order, like a parent and child kind of relationship. What do you mean by hierarchical order? Parent, child. It's a relationship, parent and child kind of relationships where we will create with RDBMS technology. Sorry, DBMS. But coming to RDBMS technology, Relational Database Management System, is another type of management system where the data points to table. Means we are going to create a table. On the table, you are going to create a columns, and you are trying to load the data. So table. So if you open the Excel sheet, what will you will see? There will be columns and there will be rows. Like same, your table also looks like a columns and rows. Columns and rows. Okay. So in the RDBMS technology, our data is pointing to the table, basically. So DBMS technology, it is like a kind of hierarchical level pattern. It is a kind of hierarchical level pattern. To break down little more, DBMS is the more basic and less structured, okay, suitable for the smaller and less complex database. Without you need to relational between the data. There is no relation, sir, internally. Means there will be parent, there will be child, but there is no relation between the data, But in the RDBMS technology, okay, it's a more advanced structure and suitable for the large complex database management systems that requires a strong relationship between data and support for SQL queries. So SQL is a language for us, basically. SQL is a language, structure, query, language. So which will fulfill using SQL language and supports asset properties. RDBMS technology supports asset properties and also supports the data integrity constraints. Integrity constraints. Integrity constraints means there is a set of business rules when you are going to create a structure. While you are creating a table, there will be a set of business rules will provide. So it means we should not allow the null values. We should not allow the duplicate values. Okay. So there should be primary key and foreign key, like a kind of relationship between two tables. And uh, for example, if you go to the bank and you wanted to open an account, they will tell that this is the minimum amount. Without deposit that minimum amount, we can't open the account for you. So there is a constraint called check. Check greater than 1,000 means greater than or equal to 1,000 means if you deposit 1,000, then only your account will be created. Otherwise, no, sir, they can't create. So that kind of integrity checks they will create when they are going to create the structures. No worries. I will take one separate session on the dev side. That time I will show you how to create a table, how to create a how to load the data, how to read the data. That time you will understand about the integrity constraints also. Okay, so just listen the theoretical part. Practically, I will show you how to create a table, how to insert the data, how to update the data, how to delete the data, how to create the store procedure, how the views are creating, how the indexes are creating. Everything we'll discuss practically also. Okay, because why Subbu, that is a development task, right? Why we want to do know means, even though that is a dev team only doing, dev team or apps team is doing, but you may also get a chance to work for the deployments, monthly deployments, weekly deployments. They will provide you the script, and that script you need to just go and execute. So usually they will handle the development deployments, but sometimes we also may get a chance to do the deployments, either monthly basis or weekly basis. So in case you get a chance to deploy the scripts, at least you should, whenever you open that scripts, at least you get some information. Oh, they are creating the data and they are loading the data. What data they are loading? Oh, they are inserting new records. Oh, they are updating records which are already existing. Oh, they are deleting the records. At least we should get idea about what they are doing. Simply blindly we can't copy the scripts and paste it and run it, right? So that too we will play with the production hours. So we need to little be careful what they are providing, what we are running. Okay, even though definitely they will be approved by everyone, but at least you should have better idea what we are running usually. So for that, I will take a separate session what dev team is doing, especially mostly next week, Monday or Tuesday. I will take one session how what developers are doing exactly. I will run the store procs. I will run the views. I will run the tables. I will load some data so that easily to understand. Okay, this is what dev team is doing. Then rest everything DBA people will do. Okay, so RDBMS to get better idea. So there is a simple to understand. See, DBMS RDBMS. So DBMS application stores data as a file. Okay, where your data is storing as a file, it is storing the data. In the DBMS, there will be file will be created, and then so for example, I can show you easy to understand. Let's go stress. 1 second. No. Hold on, hold on. You the install. Hmm, hmm, Interesting. Hey, oh, sorry. Here. See, this is a file. Okay. Oh, sorry. I mistakenly opened the wrong. See, there is a file. In that file, your data is storing. There is a file is created. In that file, your data is storing. So when you specially go for database management system, your data is storing under the file. There it will be internally, the file will be created. In that file, your data is storing. Simple for example. Now, but when you go for RDBMS, okay, your data is storing in a tabular format, nothing but table format. There will be table. See, these are all the tables. Okay, so these are all the tables. Under the table format, your data is storing. For example, when you execute this table, see, there will be columns and there will be rows. These are all the rows. These are all the columns. So how your table will be designed? So your table will be designed with the columns. Okay. So they will create how many columns they want. They will create the columns and they will set the business integrity constraints when they are going to create a table. And once the table structure is created, then they will try to load the data. It can be insert, it can be update, it can be delete, or it can be select, retrieving the data. Select is nothing but reading the data. Loading is nothing but insert, update, delete the data. Usually, these are the four operations globally we are doing. When you are going to place an order, that is the insert. When you are updating the order, that is the update command. When you are canceling the order, that is a delete command. When you are tracking the order, that is a select statement. Only 4 operations usually we'll do in the globally. Knowingly, unknowingly, we are doing these 4 operations only. Knowingly, unknowingly, we are doing only 4 operations. One is insert, one is update, one is delete, one is select. So select is nothing but data retrieval, sir. Like credit card bill, your bank statements, credit card statements, okay, and insurance statements. So statements, everything we are trying to electricity bill, water bill. Okay, these are all the select statement. We are retrieving the data. Data is already there. We are retrieving the data. But coming to insert, update, delete, as I told you, right, one of the best example. Whenever you go to the bank, first time you are creating your account on so and so bank, that time they will insert your data. Once they inserted your information into the table, then later on, if you wanted to update the address, update the mobile number, update the Gmail, so you use the update command, and you wanted to completely delete the account from so and so bank, then you will perform the delete statement. So insert is nothing but loading the new record. Update is nothing but data is already there, just you are updating the existing data. Delete means whatever the data is already available, that you are going to delete. And select means whatever the data is available, you are reading the data. So usually we will perform these 4 operations. But in coming to RDBMS, your data is storing in the form of table. In the DBMS, your data is storing in the form of files. In DBMS, data is generally stored in either in the hierarchical form or the navigational form. Internally, it is storing, sir. No need to worry. We are not using any DBMS technology. In the RDBMS, the table has the different identifier calling like a primary keys. I told you, right? Integrity constraints. Primary key, foreign key, not null, check. So, which will means protecting some business rules. Means whenever you are creating a table, you are going to set a business rules. You can't see. Best example is your passport. Everyone can understand the passport. Your passport should not be null. Your passport should not be duplicate. Every person need to have unique passport number throughout the global. So right, whenever you go to the specific country, how they are going to maintain the password? Without passport number, no passport will be generated for us. So null means without passport number, will you get the passport? No. And your passport should not be duplicate also. Number, your passport number should not be duplicate. That two things going to taken care by this primary key. Whenever you are going to create a table and you are going to specify the column with the primary key, that time it won't allow null values, it won't allow the duplicate values. That is how these business rules are setting. Okay. So normalization is also very, very important concept. Normalization is not part of the DBMS, but normalization is part of the RDBMS. What do you mean by normalization, Subbu? Means, see, there are normalization 1, 2, 3, 4, bytecode normalization 5, 6. So there are different types of normalization. Uh, when when developers or apps team or developers, they are going to create a table. See, simply they can't create a table like randomly, sir. See, they will follow some hierarchical level pattern. So, for example, if you are creating a table, for example, I wanted to decide that I need to create a table for account for two account table. Under that account table, you wanted to mention the first name, last name, middle name, your mobile number, your email address, your photo, your ID proofs, okay, and your locations. Okay, what is the min balance when you open the account, okay, and when you close your account, minimum balance, maximum balance. So everything you wanted to keep in one table. So what will happen? The columns will be massive. So we as a see in a table you can create 1,000 columns, but can I create 1,000 columns on table means the performance will impact. Usually we need to improve the performance of our databases. If performance is impacting, we won't see. For example, you decide that you wanted to book a movie ticket, and you open application, whatever the applications you are having. For example, India Book by Show. Okay, you open Book My Show and you decide to book the ticket. So whenever you open the Book My Show, it is taking some time. When you will try to go to the movie and try to book the ticket, also it is going to take a time. And once you place your payment, also it is taking time to update, and finally your payment got cancelled. So definitely, what you will get frustrated with that application. Okay. Now next time we won't use that Book My Show. We'll go for different application. Means we are losing a customer. Always performance is very, very important. You need to look from the application point of us. Means sorry, customer point of us. Of course, we are also one customers. So we are also one customers. Knowingly, unknowingly, you are opening the Book My Show. Knowingly, unknowingly, you are opening the uh, uh, any application like Ola, Uber, Book My Show, Paytm or PhonePay. So multiple applications we are opening. In case if that application is hanging or taking longer time to perform any operation, definitely you will choose one more app, because we are having multiple options nowadays. It means we are losing the customers. Always customers are very, very important for us. So how you are going to improve the performance, that is very important. So as part of the normalization, what develop see everything today we are discussing for dev side, not DBA side. But we should get an idea, sir. We are not doing all this stuff, but if you're having idea, that is very good for us. So when developers and apps teams are creating a structures, they will follow the normalization rules. Okay, for a table, this many columns are need to be there, like a parent kind of table, child kind of table. So they will make the parent and child with a relation called primary key and foreign key. So they will create the primary keys. They will create the foreign keys. See, every table max it will contain the PK primary keys. Every table will contain the primary key, and they also maintain the foreign keys. Relation between two tables, primary key, foreign key relation. So they will create the primary key. Primary key means it's like a kind of acting like a parent table. Foreign key means it's like a kind of child table. So instead of keeping all the columns in single table, we will segregate this uh, table structure. Okay, and we will make some relationship between these tables, between these two tables. So for example, see address table they are keeping on one table. Okay, address type they are keeping another table. Email address they are keeping another table. Passwords they are keeping another table. Country region they are going to create another table. And how they are going to make the relationship between the primary key and the foreign key. So if you open here, if you go to the keys, there is a foreign key. There is a foreign key. So this is the primary key and there is a foreign key. There is a relationship between these two tables. This is acting like a parent. This is acting like a child. Instead of creating everything in single table, they are going to create a multiple tables, and while they're creating a multiple tables, they are going to make a relationship between these two tables with the help of primary key and with the help of foreign key. Foreign key is acting like a child, primary key is acting like a parent. So definitely there is a relationship. That is what RDBMS is doing, sir. Okay, normalization means following the normalization rules. They are going to, while they are creating a structure, when they are going to create a table structure, they will follow these rules. These many columns, and you need to maintain the parent and child kind of relationship. All this they are going to do with the normalization. Who? Developers. So normalization is compatible with RDBMS, but normalization is not compatible with the DBMS. And DBMS does not apply any security with regarding the data manipulation. But RDBMS defines the integrity constraints for the purpose of asset properties: atomicity, consistency, isolation, and durability. Okay. So data integrity is also very, very important. Data protection is also very, very important, and it also supports asset properties. This is very, very important. I will talk more in depth in the upcoming classes. Every RDBMS technology, like all the database management system which are belong to RDBMS, need to fulfill the asset properties: atomicity, consistency, isolation, and durability. Out of this is something very important for us, sir. Okay. When we are discussing advanced level, one day we'll sit on this only. Rest of things, okay, fine. We are not that much concentrating. But this is something very important for us. Like when you are especially working with the locking, blocking, deadlocks, you must and should understand about the isolation level. So what is asset properties? What is atomicity? What is consistency? What is isolation level? What is durability? I will talk in upcoming classes. Okay. Now DBMS use the file system to store the data so that where it will no relationship between the data. But RDBMS will maintain the relationship between the data because you are going to store your data with the tables and you can keep the primary keys, you can keep the foreign keys so that you are having a relationship between these two objects. DBMS has to provide some unique methods to access the storage information. If you wanted to access, so it contains the unique process. But RDBMS supports the tabular structure of the data and the relationship between them, access the storage information, where you can use the join conditions, subqueries to retrieve the data in the RDBMS. So there are different join conditions, there are different subqueries. Using the join conditions, using the subqueries, okay, you can retrieve the data and I can see the data between across the different tables. Across the different tables, I can. So DBMS does not support the distributed database, but RDBMS will support the distributed database. Means across two different databases, we can access the data. Okay, if while creating the linked servers, okay, you can create the linked servers and you can get the data from one database to another database, another database to another database. We can get the data. Means cross database access. For example, I'm having the data in this data. So you are having a different. So this is database. From this database to I need to access here. Okay, I need to distribute some data from here to here and here to see. Every database is a unique. Every database is a independent. Okay, there is no relationship itself. But even though there is no relationship, if you wanted to get the data from this database to this database, this database, this database, it is possible. It is possible with the RDBMS. That technically we are calling as a cross queries. Technically we are calling as a cross queries. And DBMS is meant to for all smaller organizations, okay, to store the data, but nowhere we'll use it, sir. We'll completely working with our RDBMS technologies only. Okay, multiple users can access the data. Best examples for the DBMS is XML and file system. Okay, example for the DBMS are file system and XML. But best example for RDBMS is MySQL, Postgres, SQL Server, Oracle, etc. These are all falls under RDBMS technologies. So XML data, file system data will falls under DBMS technology. So where you will create a file and you will try to load the data and you will create the XML kind of data. So these are all falls under DBMS. But when you go for RDBMS, like a MySQL, Postgres, SQL Server, Oracle, these are all falls under our RDBMS technology. Any questions? Anyone? So this is just
there no technology for DBMS?
No.
Like we have MySQL and SQL Server for RDBMS.
All are RDBMS, sir. All are relational database management systems.
Oh.
See, to generalize this one, there is a website called DB-Engines. So these many database management systems are there. Okay, so these many, almost 389 database management systems are there throughout the global. We know only top 10, I think so. Majority of them we will remember, like Oracle, MySQL, SQL Server, Postgres, MongoDB, Snowflake, SAP HANA, DB2, Redis, Cosmos DB, Cassandra, Amazon Aurora, okay, Sybase, at least 10 plus database management system we know them. But almost 389 database management systems are available throughout the global. Okay, so see, you will get to know, for example, this node 4j is falling under graphic, okay, database. So if you wanted to store graphics, more graphic related information, so node 4j, they will use it. So if they wanted to go for multi-model, multi-dimensional model data, they will use the Microsoft Azure Cosmos DB. So ClickHouse is also following relational database management system. PostGIS is following the spatial multi-model database management system. Spatial is nothing but if you wanted to store the location related. So you know about the location, right? Longitude, latitude, graphical. So geographical locations, longitude, latitude. In case you are mostly spending the loading the data in terms of geographical locations, then we'll go for spatial. Even SQL Server will also allows the spatial. Postgres is also allows the spatial data. So there are many, sir. Will we remember all this stuff? No. If you wanted to store your data in form of documents, we can go for this database management system. See what sort of data we are going to store. Based on that, you will choose any database management system. That is what I wanted to say. Okay. But mostly, most popular are this top 5: Oracle, SQL Server, MySQL, Postgres, MongoDB. These are all the top database management system. All are falls under relational database management system. MongoDB is something different, sir. Mongo is like a documented kind of stuff. Okay, document. It's not like a traditional. It's like a NoSQL kind of stuff. MongoDB is a NoSQL. The rest of all are like a SQL RDBMS technologies. This is NoSQL kind of stuff. You are going to store your data in the form of documents, like a JSON format. Internally, you are going to store your data in the form of JSON code. I hope everyone clear by seeing this one. So what sort of data you are going to store? Based on that, you will choose your database management systems. We'll choose our database management system. If I click here, I will get little more information like what sort of languages it is important, what sort of data it is storing, what sort of features, everything you will get it here. But not everything, but minimal information will get it. So this is about DBMS and RDBMS. As I told you, we are having different types of database management systems, like different set of database available, like hierarchical level database, network database, relational database management system. Just now we discussed about a relational database management system, object oriented relational database management system. Okay. And what is mean by hierarchical level means this database employ like a parent and kind of chain relationship, hierarchical level. So for example, how I can understand how I can say you in a simple layman terms means, so there will be one file will be created, okay, like a Hadoop kind of features. Hadoop is also like a hierarchical level pattern internally it is storing. Hadoop, big data clusters, Hadoop. Okay, there will be there is a directory. Under the directory, you are going to create a files, and there is one more directory, and under that there is one more directory. Means in this directories you are going to keep the files, and you can restrict the access. You can allow the access. See, usually in a technical layman terms, you are going to create a folders. Okay, there is a folder. Under the folder again there is a folder. Under that again there is a folders. For example, there's a folder. Again that there is a folder. Again there is a folder. So this is simple, like a traditionally we'll call it as a directories. There is nothing called hierarchical level pattern. But when you are choosing like a hierarchical level database, so there is a relation between this directory to this directory. You can control these directories. Okay, like a kind of Hadoop capabilities. Hadoop is also working like a hierarchical level pattern. So if I wanted to grant the access only to this directory, I can allow. If I wanted to restrict this, I can allow. I can restrict. So this is all possible when you go for hierarchical level pattern. but not in a traditional. Traditional, everyone can go to here, go to here, go to here. But once you enable, so you can control the access, you can control the database, means data management, everything with the hierarchical level pattern. Everything you can control with this hierarchical level pattern. So like where you can find like a parent and kind of relationships. Okay, old and database management systems are no more now. Network, okay, database management means many to many. Okay, network database supports many to many relationship. So like a relation to the complex database structure, many to many. There is nothing like a one parent, one child. Means one parent, multiple childs. See, there will be parent and you are having a child, multiple childs. Okay, you can when you go for hierarchical pattern. But network DBMS means multiple parents, multiple childs. So many to many relationship they are going to make. It's like a very complex database. It's like a very complex, not like a traditional database, sir. Don't think about traditional databases. Not like a traditional database. There will be many to many, many to many. But when you go for a relation database management system, as I told you, right, you are going to store your data in the form of tables. You are having a database like Oracle, MySQL, SQL Server, or you are going to store your data in the form of tables only. But when you go for object-oriented relational database management system, this DBMS supports the storage of the miscellaneous data type that store the information like name, IDs, genders, like attributes. So whenever you are going to create the structure, whenever you are going to create the table structure, where you can create the different attributes to store your data. For example, Postgres is object-oriented relationship also means when I'm creating a table, I can load the data in the form of JSON. Okay, JSON is a language, sir. Is a language, object-oriented language, like Java, C, C++. JSON is also language. So you can store data in the form of JSON code. You can directly store your data in the form of JSON code. So these many different databases are available. Usually, will I get a chance to work all this? Subbu means no. You will get a chance only to work with the relational database management system. But to understand more, these many database type systems are available, like a hierarchical level database, network like database, object oriented database. See, I can give you one more example to understand. There is if I go to the Postgres. Okay, see, it stores the document, stores graphics, okay, spatial vector information. If you scroll down, not this one, where it is, where. Hold on, sir. Let me store graphics, object-oriented database. Okay, so these many are the object-oriented database management systems. These many. These are all the database which are mainly sitting on the object-oriented database systems. Okay, if you want the documented store, these are all the databases which are sitting for like a document. One of the most popular is MongoDB. And if you want to do key value store, you will go here. These database systems are sitting on the key values. So we are having varieties of databases are sitting. Most popular is RDBMS. We are working mostly on the RDBMS. So whenever you are getting the project, which database you are getting support. So sometimes you will get a chance to work with the Redis. Sometimes you will get a chance to work with the Solid DB. One of my friend only, when he got selected, he told that I got a chance with. Actually, he's a SQL Server database administrator. He's told that I need to support the Solid DB also. Do you have any idea? Then I also get short. What What is solid DB? First time I'm also listening that terminology. Then luckily I found this website and I came to, okay, this many database management systems are available in the global. Okay. Out of this, we know a couple of things. So majorly they are storing different varieties of data. Got it, everyone? No? Yes? Any questions? No questions?
No,
Okay. Now, all these database management systems, okay, all these database management systems, okay, will follow one language as a SQL language. One of the most common language they will follow is a SQL language, structure, query, language. Okay, SQL stands for structured query language. SQL is a compute language used to interact with the relational database management system. Okay, where you can organize the data. See, SQL is a tool for the organizing, managing, and retrieving, archiving the data from the compute database. Okay, so SQL, when SQL is a language, so like C, C++, Java, .NET, PHP, WordPress. So you are having different language like R language, Ruby language. Okay, PySpark, Gusto. These are all the different languages, right? Out of that, SQL is also one language which is commonly used for all the database management systems. Which is commonly used for the all the database management systems. SQL is as a language. So SQL was invented in 1970 and was the first completely distributed by the Oracle. Oracle people only started this language because that time there is no Microsoft. Microsoft is not holding any database management systems. IBM is the ruling the database management system that time. The original name was given by the IBM as a structured English query language. Okay, and slowly that has been converted into the SQL. SQL is a American National Standard Institute, ANSI. It will support the ANSI standards. That is, ANSI value is also one of the most important concept when you are especially working with the performance tuning, ANSI padding, ANSI null, ANSI variables. Okay, when we are driving the performance tuning at the advanced level, I will take one session on this ANSI also. Sometimes these ANSI values also may impact the performance. What is ANSI padding, Subbo? What is ANSI null? What is ANSI? Means what exactly they are doing internally. You have better idea when we take that session. And sometimes we are missing the ANSI values, and we are mainly concentrating on the why my query performance is impacting. Usually your indexes are good, statistics are good, query is designed properly, everything is working fine. Due to this ANSI only the performance is impacting at the application level, at the SQL level. Okay, so what is the ANSI values you enable at the SQL level? What is the ANSI value you enable at the application level? What do you mean by ANSI? This is what we wanted to understand. That time I will talk about this one little more interesting. Okay, little more so that you will become strong at the ANSI values also when you are tuning the queries. Especially, sometimes the people who are experienced people, you will get this question. I am running a query. My query is running faster in SSMS, but my query is not running from the application side. When I'm running the same query at application, it is taking longer time. When I'm running the same query at SSMS, it is running little faster. Now, what is the main reason means this ANSI values may impacting. Sometimes application team will enable different ANSI values. At the SQL side, we are having different values enabled. At application side, you enable different values. Due to this ANSI conflicts, the performance will impact. So how I can overcome, how I can see these ANSI values, what exactly they are doing internally. So I will take a separate session when we are going for query tuning. That time you will understand. So SQL is a language which supports the ANSI values, ANSI standards, operates the multi versions and the frameworks to handle the backend data across the various web servers, app servers, VB servers to access the relational database management system like a MySQL, SQL, Oracle, Postgres, and other database management systems. Got it, everyone? No? SQL is a
Got it.
language, basically. And SQL having 5 different languages like DDL, DML, TCL, DRL, TCL. So as I told you, I will take a separate session on the dev side. I will talk about that day about all these languages in depth. Okay. As of now, SQL is a language, structured query language. Okay. Where you are having 2 different things you will perform. One is using these commands. See, SQL is a language. In that language, again, you are having subly 5 languages. One is data definition language, data manipulation language, transaction control language, data retrieval language, and data control language. And each language is having different commands. Using these commands only, you are going to perform massive stuff. Okay, what is these commands? What is this functionality? I will talk when I'm taking the dev session. As of now, don't worry. SQL is a language commonly used for all the database management systems. Okay, but coming to that, you will have one more language also you will hear. Like, see, when I go to the SQL, commonly SQL is a language. See, SQL is a common language for all the database management systems. But you will have one more language called T-SQL language. In SQL Server, you will call it a T-SQL language. In Oracle, you will call it as a PLSQL language. These are all programmatic languages. Okay, this is a standard language where we are going to use for all the database management systems. And there is one more language also. With this, sir, again, we are not doing anything strange thing here. Using this only, we are doing the programmatic language. See, these are all like a ad hoc request. See, when you are running justly simply one select statement, okay, this is one ad hoc request. Okay, this is one ad hoc request. But same query, if you're returning in begin tran and end, this is a kind of programmatic language. So same select statement only. You are not doing anything, but you are going to keep in the begin tran and end tran. That technically you will call it as a programmatic language. So there are 2 types of here you will perform. One is traditional ad hoc request. One is programmatic language. So under the traditional, mostly you will perform the select, insert, update, delete, all the stuff. Okay. But under the programmatic language, what you will do, you will write a massive programs. What is that programs? Okay. So like if you expand, stored procedures, functions, triggers. Okay, these are the 3 objects we'll do. This all falls under programmatic language. Okay, you will create the massive stored box. You will create the functions. You will create the triggers. This all falls under programmatic language, like a T-SQL language or PLSQL language. Either you go for MySQL, Postgres, any database management system, you will create the stored procedures, functions, triggers, not user developers. Will create the stored box, functions, triggers. Okay. And as a DBA, we need to troubleshoot in case some stored box are running slow. Okay. Why the stored box is running slow? What exactly in that stored box they are doing? See, again, in that stored box, they are doing insert, update, delete only. They are not doing anything strange here. Whatever you are learning in the SQL language, like insert, update, delete, or create, drop, truncate, whatever you are running the commands, same thing they are going to place in the programmatic language. Okay, where they can save where they can save it and they can call multiple times. See, this is a simple query. For example, this is a simple query. When you run, you will get the data. If you close this one, again you need to write that statement once again. But you are not storing anywhere. Okay, but same thing. If we create in terms of store procedure, it will save here. Okay, it will save here. In the future, I can call it whenever I want. I can call it. In the future, I can call it. Okay, this is the stored proxy. When I go to the stored proc also, what they are doing? Okay, see, they are going to perform one select statement. Again, they are retrieving one more select statement. Again, they are retrieving one more select statement. Same thing, they are not doing anything strange. Here also, they are writing select statement, insert, update, delete only. But they are going to save this one. So in case in future, if I wanted to execute again, I can execute. I can see the progress. I can execute multiple times. So this is a programmatic languages. Under the programmatic languages, mainly they will create the store procedures, functions, triggers, and assembles different, sir. Okay, but stored procedure is very important. Functions. When I go to the functions, again they will create the different types of functions: table valued functions, scalar functions, aggregation functions. So they will do different steps. What do you mean by function? What do you mean by stored proc? What is the difference between stored proc and function? Even you are a DBA, definitely will ask these questions. Okay, so that's the reason I told you that I will take one separate session where we will talk more on these concepts only. What is stored proc? What is function? What is the difference between function and stored procs? How many objects we can create in SQL? That means all the database management system like tables, views, indexes. When I go here, indexes, okay, store procedure, triggers, sequences, materialized views. So we'll create this many objects internally. So what they're doing, your developers, your apps team, your testers, your end users, they're doing all this stuff. But what as a DB I am doing, I am just maintaining this database, So whom I need to grant the access, whether this database is healthy or not, whether SQL engine is healthy or not. While application team is accessing their database, they are experiencing any performance issue. So this is the task we are doing. We are not developing anything, sir. Don't get afraid like, okay, we are doing any development task. No, nothing. We are not developing anything. We are just maintaining the databases. But as a DBA, we must and should understand what exactly they are doing in the background. Okay, your developers, your end users, your customers who are accessing this database, who is having access to the database, what they're doing. So we can protect those connections. Otherwise, everyone can see anything, sir. Okay, how to restrict the users, how to restrict at the object level. So these are all will comes to the DBA task. So there is a two languages. One is a SQL is a common language for all the database management system. One is a programmatic language. Only two languages we'll use. And that programmatic also we are going to use the SQL as a language, sir. Got it, everyone?
Yes, sir.
So just relax for 5 minutes, sir. Okay. Any question before? Anyone? Any questions? This is just informational message sessions are nothing great. We discuss technical, but at least now you know that okay, we are having different database systems like hierarchical database system, network database system, relational database management system, and object-oriented database management system. So we are having different database management systems. And what is the relationship? What is the difference between DBMS and RDBMS? So DBMS will store the data in the form of files. RDBMS will store data in the form of tables. DBMS doesn't support the ACID properties. RDBMS will support the ACID properties. DBMS that doesn't support the normalization. RDBMS will support the normalization. Okay. The best example for the DBMS is file system and XML format. Best example for the RDBMS is all the database management systems will fall under. Majority of the database management system will fall under RDBMS. Just remember these points are enough. You no need to remember all the points, whatever we displayed. Okay. Just remember 4 to 5 points. That is well and good. At least you have some core knowledge. Okay.
Okay.
Okay, just relax for 5 minutes. I will start the architecture, sir. Okay, just relax. Nothing. Don't think anything. Okay, just relax. Everyone back?
Yes.
Yes.
Yes. See. As a database administrator, before we discuss about the SQL, everything, what are the features, all this stuff, first we must and should understand about the architecture. Okay, how SQL Server Engine is processing internally. So SQL architecture will plays a major role in terms of not only SQL, sir. If you go for any database management system, architecture will play a major role. Okay, so if you go for Oracle or any other database management system, how internally engine is processing your request. It can be modification, it can be data retrieval. So you will do either two things only. One is loading the data, one is reading the data. Either you load the data, either you will read the data. So what exactly is happening when you are loading the data? What exactly is happening when you are reading the data? So that is what we need to understand little more. So that is what first we are going to discuss. So as part of architectures, there are different varieties of architecture in SQL Server, especially like SQL Server architecture means entire engine architecture, storage architecture, log file architecture, TempDB architecture, memory architecture. So we are having different architectures. Okay, slowly I will make that architecture also little to make you strong. As of now, we are in the beginning. As of now, we are going to discuss first about the SQL Server architecture. Okay, first our main constant is a SQL Server architecture. So usually we will go to the Google and we will search for SQL Server architecture. Simply, before I present something, imagine just you went to the Google and you research something. Okay, like a SQL Server architecture, you will find lots of images, lots of documents here, and you will most of the documents whenever you open any doc, most of the images, any images if you open, mostly you will see, okay, there is a network, there is a, it is going to the protocol layer, then it is going to the relational engine, and you will see the storage engine. Under the relational engine you are able to see the optimizer, command parser, query executor. Under the storage engine you are seeing the buffer manager. Under the buffer manager, you are able to see the plan cache, data cache, and buffer pools. You are seeing the access method, transaction manager, transaction log, data files. And if you go here also, almost it is also looking like the same only. Here also you will see the network, protocol layer, relational engine, storage engine. Almost majority of the images are showing in a simplest way, and mostly you are seeing same thing. But when you search for Oracle architecture diagram, if you search for Oracle architecture diagram, definitely will love it, because see how they design the architecture in each and every minute thing they documented well. So whatever you are able to see, same thing here also we are able to do. Okay, whatever you are seeing in this diagram. Okay, how complex you are thinking that, okay, SQL is very easy, where we are having only less components. But when you go for Oracle, these many things are available when you just click on open. So these many things we are doing. Same things we'll do on the SQL also. Same thing we will do under the SQL also. But only the problem is the diagram. Yeah. Okay. So see, whatever you are able to see here, almost the same thing you will see for SQL also. But our presentation is not that much nicer. Not sure why Microsoft is not concentrated this one. So you could prepare a best architecture diagram so that easily to understand for everyone. Like Oracle, I love the Oracle a lot. So they mention every minute thing here also, here only. So we can get everything massive stuff here only. But when you go for SQL, uh, you can't find that much information. But whatever Oracle people also doing, almost SQL also will do same thing. SQL also do same thing. So whenever you when you search for something like a SQL architecture, okay, you will find lots of images. Okay, like this, lots of images. So one of that, I just loved it. This one, at least better, somewhat betterly they projected. So usually when you go here, you will see three layers. One is protocol layer, one is database engine layer, one is SQL OS layer. So in SQL architecture also there are three different layers. One is protocol layer, one is engine layer, one is SQL OS layer. So these three layers, it's a three layers. When you especially go for architecture, it's a three layer architecture. One is protocol layer, one is engine layer, one is SQL OS layer. Okay. So as of now, we are not concentrating anything on SQL OS. Okay. When we start advanced level, again, I will talk about this SQL OS architecture. Of course, we are discussing SQL architecture only, but today our main concept will be these two layers. We are not concentrating anything on this because the people who are first time listening, they don't know about what is the scheduler, what is a worker, what is a task, what is a preemptive schedulers, what is corporative schedulers, what is the master slave architectures. There are a lot. So it's tough to understand this hierarchical level pattern. So what I will do, that's the reason. This architecture I will explain when we are troubleshooting CPU. Mainly when we are discussing, when we go for advanced performance tuning, that too when we are discussing CPU. And that day I will talk about first SQL OS architecture only. There you will get the schedulers, buffer, logs, everything you will get it when we especially go for SQL OS architecture. And I will share separate document also, sir. As of now, our constant will be only these two layers. One is a protocol layer, one is a engine layer. So when you are trying to, as I told you clearly, okay, SQL Server will follow client server architecture. There will be client, there is a server. So see, SQL Server is a Microsoft RDBMS that works on the client server architecture. Okay, here end user will send a request to the SQL Server. SQL Server will accept, process, and share the result to the user. That is what it is happening. So once you got the request, SQL Server will accept the request. SQL Server will process the request. SQL Server will share the request, sell the results to the user. That is what internally it is happening. So internally it is very easy, sir. See, it seems a very simple process from the front end. However, there are multiple processes running in the background to fulfill this request. So we need to understand what is happening in the background, not in the front end. So in the front end, what you are doing, you are writing a query. You are simply writing a query, select star from sales dot sales order details, and you are executing the query. And it took almost 1 second to complete. You got the results. In the front end, it is very easy. I just connected to the SQL and I'm processing something. In the front end, it is very easy. In the background, what is happening? That is what we need to understand, sir, basically. Okay. So to understand that one, we must and should know about the SQL core architecture. SQL core architecture. That core architecture is nothing but our engine architecture, our database engine architecture. So that is what in this image also they are clearly saying that engine and protocol. So today our main focus will be protocol along with the engine. So first we'll discuss about the protocol, then we'll discuss about the engine. In advanced level, I will talk about the SQL OS architecture. As of now, we are not touching any concept called SQL OS architecture. We'll mainly concentrate on these two only. See here more on theoretical. I will spend more time on theoretical, but upcoming classes I will more sit on the practical, like a parser, optimizer, okay, and data cache, plan cache. I will talk more practical in the upcoming classes. But here more will sit on the theoretical part. As I told you, right, first initially we'll sit more on theoretical part, not on anything on practical. But somewhere, somehow, somewhere I will show you little practical. But if you're not understanding, it's okay, fine, sir, practical. Once you become strong in the SQL, Again, I will go for in-depth architecture walkthrough. That time you will understand easily. Each and wherever we need to stress the practical, I will stress the practical so that you will become strong. First, let's go for again presentation, sir. So, one is protocol. Our main constraint will be the database engine only. But under the database engine, there are two engines. One is a relational engine, one is the storage engine. See, you are connecting to the database engine only when you are trying to connect to the SQL server. When you are trying to connect to the SQL server, you are connecting to the database engine only. But under this database engine, there are two engines are working. One is a relational engine, one is a storage engine. So under this database engine, there are two engines are working in the background. One is a relational engine, one is a storage engine. So relational engine is like a query processing. Your query is processing. There is nothing called data. In the relational engine, there is no data. Your query is just processing under the relational engine. How it is processing, that is what we will discuss in a while. Okay. In the storage engine, there will be your data is storing temporary. Your data is storing temporary. Okay. So what about storage engine? What about relational engine? How the data is processing? How we are getting the data? That is what today main focus is, these three parameters. Okay. SQL OS I will talk separately, sir. Okay. So now whenever you open the task manager, if you open the task manager, if you simply click on here, open the task manager, if you go to the details, you will see SQL Server.exe. Means, okay, in this server, there is one instance is running, SQL engine is running. Whenever you see the SQL Server.exe, means, okay, one engine is running here. Okay, one SQL engine is running. So that is what I presented here, sir, easily to understand. Okay, whenever you go to the task manager, you will see SQL Server.exe is running. Means one engine is running, one database engine is running. You can install one more engine also. Okay, like that you can install maximum 50 engines on the same server. Within the server, you can install 50 engines. 50 times you can install the SQL server within one server. Okay, that many times I will install in the real world, Subbu? No, sir. But you can install multiple times. You can install multiple times on one single server. On one single server, you can install multiple times. How many instances I can install? What do you mean by instance? We will talk, sir, in the upcoming classes. Okay. As of now, our main constraint will be protocol layer. Our main constraint will be the database engine. Under the database engine, relational engine, and storage engine. Now, first, end user will send the request. For example, it's a select statement. Means, what do you mean by select statement? Reading the data. When you are reading the data, okay, how that read operation is happening. Today, our main focus will be the read. Tomorrow, our main focus will be the write. Okay, when you are writing the data, how it will process. When you are reading the data, how it will process. Today being the first day, I will concentrate more on the read. Okay, tomorrow I will concentrate more on the write, so that you will become strong in the read and writes. Everyone mustn't be strong in the read and writes. Otherwise, we can't become strong in the architecture basically. So imagine you are reading the data. Okay, first it will go to the operating system where you install your SQL. First, it will go to that operating system to establish the connectivity to the server. Once it establishes the connectivity via network, via SNI, okay, SQL Network Interface, via SNI protocol, and it is using the TDS, tabular data stream. It is connecting to the SQL. Via network, it is connecting to the SQL. So what do you mean by network, Subbu? I'm not understanding. Means, so SQL Server Network Interface is a network protocol layer to connect to the DB engine. Okay, if you wanted to connect to the DB engine, any one protocol need to be running. If all the protocols you will disable, you can't connect to the SQL. At least one protocol need to be enabled. Either it can be shared memory, it can be named pipes, it can be TCP/IP protocol. It can be TCP/IP protocol. At least one protocol you need to be enabled. If none of the protocol is enabled, you can't connect to the SQL. You can't connect to the SQL. Okay. How before it connect to the SQL, it is going to the protocol. Once it connect to the operating system, it is going to the SQL network interface protocol. Okay, to establish the connectivity. Once it establishes the connectivity via TDS only, it is transferring the data. Means TDS stands for tabular data stream. Is an application layer protocol used to transfer the data between database engine to client. It's like a kind of package, sir. Packets, network packets. See, you are simply running the select statement only. Whenever I go to the new query window, I am just simply running the select statement. Select start from sales dot sales order details. You are simply running the select statement in the front end. But what is happening? This operation is transferring to the SQL Server via packets, network packets. In that packet only, what your information is holding. What information is holding? This select statement information is holding. So via TDS packets, your application and your engine are mutually talking to each other. Actually, this package is designed by the Sybase for the Sybase database management system in the year 1984. Okay, we are in 2026. Still, we are using this only, sir. Okay, still we are using this only, tabular data stream only. Tabular data stream only while we are transferring the data. How the data is transferring across SQL to application to SQL via network packets. Via network packets, your data is transferring. To establish that connectivity, we are going to use these three protocols. See, your data is transferring via packets, network packets. To establish the connectivity, we are going to use these three networks. Either it can be shared memory or named pipes or TCP/IP protocol. Any one of this protocol will use to make the connectivity to the SQL. So either any protocol need to be run, sir. But let's talk about each and every protocol. What is the shared memory? What is the named pipes? What is TCP/IP protocol? The first protocol we are going to discuss is the shared memory. Okay, and this is the default protocol which is running. Okay, so shared memory means, imagine this is your server where you install SQL. Okay, this is our DB engine, and here also there is a client. For example, SSMS is a client. Okay, client. In this server itself, there is an engine, there is a client. Both are running on the same only. Both are running on same. Okay. In this time, if your client is trying to make access to the SQL, then definitely they will use the shared memory. Okay, shared memory. Within the server, if you are trying to access the SQL, by default, SQL Server will use the shared memory protocol to connect to to make the connectivity. For the connectivity, it is using the shared memory. If someone is asking what is the shared memory will be used when we are when the DB and the client are in the same server. If the DB and client are in the same server, by default it will use the shared memory protocol. Okay, fine, Subbu. I understood. Now let's talk about TCP/IP, sir, before I go to the named pipes. TCP/IP is the most widely used protocol. Okay. For example, this is one server where you install client. This is one more server where you install DB. So both are two different VMs, two different servers, two different VMs. One VM There is a DB engine, one VM, there is a client. Now your client wants to access the DB. Means if you want to connect SQL Server remotely, this is the terminology you need to remember. Remotely. When you are accessing SQL Server remotely, by default, it will use the TCP/IP protocol. By default, it will use the TCP/IP protocol. If you want to connect SQL Server remotely, if you disable this one and trying to connect remotely, you can't establish the connectivity. The network communication failure alert you will get it. You can't connect to the SQL Server if TCP/IP protocol is not running. So if you want to connect SQL Server remotely, you must and should enable the TCP/IP protocol. Getting my point, everyone? When you will go for shared memory, if my client and DB are sitting on same server, by default, it will go for the shared memory. When your client and DB in sitting in different servers, then by default, it will go for the TCP/IP protocol. Okay, being it is connecting remotely, I need to secure my connections. See, being it is connecting remotely, we need to secure our connections. To secure our connections, we are enabling the port for TCP/IP call. 1433 is the default port number for SQL. Default port for the SQL is 1433. The default port number for SQL Server is 1433 port number. Okay, which is TCP/IP port number only. If you want to access SQL Server remotely, okay, then we must and should enable the TCP/IP protocol. So if you are enabling TCP/IP protocol, you need to set the port number. The default port number for TCP/IP protocol is 1433. And technically we'll call it as a SQL Server port number is also 1433. Can I change that, Subbu? Yes, you can change it. So when you will go for TCP/IP protocol, if you are connecting SQL Server remotely, we'll go for TCP/IP protocol. If you are connecting SQL Server locally, then by default it will use the shared memory protocol. Is it clear first to everyone?
Yes, Subbu, clear.
Yes, sir.
Now, what is the named pipe, Subbu, then? So you know about the LAN cable, LAN. Okay, see every laptop, if you go here in your laptop also, there will be one LAN port will be there where you can keep the LAN wire. Okay, direct access. Okay, so whenever your application and DB, okay, are talking via LAN cable, then we'll use the named pipes. Otherwise, no, sir. Otherwise, no. Okay, 99.9%. This is a dead feature. No one is requesting to enable the named pipes, sir. Okay. Named pipes is nothing but when your application and the DB is talking via LAN cable, then definitely they will ask to enable the named pipes. Then we will enable the named pipes only if there is any application compatibility. Otherwise, always it will be disabled mode only. Always it will be disabled mode. We won't enable, sir, because there is a concept called SQL hardening. Vulnerabilities. There is a concept called SQL hardening. As part of SQL hardening, named pipes should be disabled mode. As part of SQL hardening, named pipes should be in disabled mode. So that is the reason it will be in disabled mode, sir. But if there is any application dependency, application team is telling that, okay, we must and should enable the named pipes. Then only we will enable, otherwise, no, sir. Otherwise, we never enable the named pipes. So these are the three protocols you will see. But before 2005, we'll see one more protocol called VIA. There are four protocols actually. One is already duplicated. Mostly we named pipes also will be duplicated. So no more we are using LAN cables. Okay, in the Year 2026, we are no more will use the LAN cables. VIA, there is one more protocol earlier. VIA, Virtual Interface Adapter. VIA stands for Virtual Interface Adapter. Okay. So, for example, if your client and DB is interacting via Wi-Fi, okay, we used to enable the VIA protocol. I also not get a chance to enable this one. At least named pipes twice I enable, but the VIA I never see, sir. I never enable this. But just to remember, just to add on, when you are trying to crack the interviews easily, how many protocols are available means at present we are having only 3 protocols, but in the older system we are having one more protocol, VIA, Virtual Interface Adapter. Whenever our client and DB is interacting via Wi-Fi, we used to enable this protocol. Is it clear, everyone? No? Yes?
Yes, Subbu.
Yes.
Sir, hello.
Yes.
Sir, if I disable the shared memory, it will run my query in the same server, sir.
Yes. TCP/IP protocol. At least one protocol need to enable, sir. I will show you practically.
Not
I will
TCP.
disable. Yeah, I will disable all the protocols and I will show you practical demo. Okay. Because we need to install SQL Server, right? Without installing SQL Server, you can't understand. So first, let's install the SQL Server. Then I will show you practical demo. First, I will disable the shared memory and I will allow the connection. Next, I will disable the TCP/IP. Then I will allow the connection, and I will also show you the remote connection. Okay, so that you will become strong in the connectivity. Not only this, sir, there are a lot again. Okay, like NTLM authentication, Kerberos authentication, SSL protocol, TLS protocols, SSL certificates. There are a lot. Okay, especially for experienced people, don't think that this is only done. No. There are lots, sir. I need 2 to 3 days time to discuss all this stuff. NTLM authentication, Kerberos authentication, TLS protocols, SSL protocols, SSL certificates, ASPNs, private endpoints, public endpoints. Oh my God, we'll talk too much in terms of encryption, in terms of connectivity, sir. Okay, don't think this is I told you, right? Basic only I'm touching here. I am not going for any deeper. As of now, I am not touching any deeply, sir. I am just going for the basic architecture. This is a very basic core architecture. This is good when you are explaining to the interviewer. Okay, but in terms of real world, we need a lot. That is lot we will discuss in the advanced level. Okay, so 1 month we are spending all for this concept only. Got it, everyone? No? Yes? Yes. Okay. Now, once you establish the connectivity to the engine, via packets, network packets, you are trying to connect to the engine. Once you connect to the engine, there are again 2 engines are there. One engine is a database engine, sir. See, before I go into that, it's simple to understand. For example, you are reading the data or you are loading the data. So first, what will happen? Via SQL Server Network Interface, you are going to establish the connectivity. See, SQL Server Network Interface establish the network communication through network protocols like shared memory, named pipes, TCP/IP protocol using packets, network packets you are establishing. Once it is done, okay, next thing is there is a SQL OS architecture will come. Okay, SQL OS architecture will come. On that SQL OS architecture, so SQL operating system, see, your database engine is not having capability to talk to OS engine. See, on top of operating system only, your DB engine is sitting. So SQL also need CPU, SQL also need memory, SQL also need the IO, SQL also need the storages. Who is going to talk to your Windows to get these resources? Means not your database engine, sir. Your database engine is not having any capability to go and talk to your operating system. So who is going to talk to your operating system to get the CPU, to get the memory, to get the IOPS. Who is going to talk? Your SQL OS is going to talk. Your SQL OS is going to talk with the Windows operating system. Your SQL OS engine and SQL and Windows OS engine are talking to each other to get the resources in terms of CPU, in terms of memory, in terms of IO. So how you are getting all this stuff? Via SQL OS architecture only. So once your connection is established, now SQL OS will come into the picture to get the OS level information like SPID. See, it is allocating one SPID, session process ID. Whenever you open the task manager, you see the SPID, so it's a 57. So how you are getting this one SPID? Who is getting this SPID? Who is getting this SPID? Your OS. SQL OS is allocating this SPID. See, whenever I open, I got one more SPID. Whenever I open, I got one more SPID. So who is getting this SPID? Your SQL OS is getting this SPID. Session process ID. Now, whatever you can do so. So once you start running only, the allocation will happen. So this much memory I need to allocate, this much RAM I need to allocate, this much of CPU amount I need to allocate for so and so query, whatever query you are running. Simply if you open, anything is happening, Subhu, means nothing is happening. If you simply open, nothing is happening, sir, here. Until unless you start performing the operation. Until unless you start performing, nothing is happening. So your SQL OS is going to talking to the Windows OS and getting one session ID first. Once your session ID is allocated, then it will connect to the DB engine. Now under the DB engine only the process is happening. So once it connect to the DB engine, now the process is happening, so actually. Okay. Once we connect to the DB engine, now everything is happening here only. So on top of the DB engine, there is network protocol, there is SQL protocol, SQL OS architecture, SQL OS network protocol. Once it processes the network protocol, once it get allocated the SPID, now it will connect to the database engine. This is our primary component. Database engine is our primary component where everything is processing, your query is processing in terms of security management, locking management, everything is doing by the database engine only. Under the database engine, there are two engines are there. One is relational engine, one is storage engine. Under the database engine, one is relational engine, one is storage engine. So we must and should understand about what is relational engine is doing, what is storage engine is doing. What is relational engine is doing, what is storage engine is doing. So try to understand. Once you connect to the SQL server, now your query will go to the relational engine first. Under the relational engine, there is no data. It is just processing your request. It is just processing your request. Your relational engine is processing your request. What it is processing? What it is processing means, before it process, you should understand about these three components: command parser, query optimizer, query executor. Okay. So first, command parser. Once it enter into the database engine, under the database engine, again, you will see the relational engine. Under the relational engine, there are three components. One is command parser, query optimizer, query executor. First, we'll discuss about the command parser. Under the command parser, first it will check the syntax checks. See what it will do, Subhum, is first it will check the syntax. Select, okay, for example, from sales order details. For example, you written one statement. Whenever it enters into the relational engine, first it will parse it. Internally, it is, see, externally you are parsing, but internally it will parse it. You no need to do anything, sir. Externally you are parsing. Okay, it will parse the request. Now it will show that whether there is any syntax error. It will show the syntax error. For example, by mistakenly you written okay like this, and you are parsing. Now see, it will show incorrect syntax error. Incorrect syntax error near sales. Near sales, there is an incorrect syntax. So command parser will check the syntax checks, whether you properly written a select statement or not. Not only select statements are insert, update, delete, sort function, triggers, whatever you are writing, whether you properly written or not, is there any syntax error or not. So first command parser will check the syntax checks. Once your syntax checks is passed, then what it will do? Okay, once your syntax checks is passed, then it will do the semantic checks. Internally. Okay, I am not understanding, Subbu. What do you mean by semantic checks? Okay, first, so your syntax is perfect. Select star from sales order details. Okay, so now it is doing the syntax checks. Okay, my syntax is perfect. Next, what it will do, right? What do you mean by semantic check? What do you mean by semantic check? Means it will go to this database, verify whether this table is available or not. Okay, and for example, here I am writing some columns. Okay, for example, I written some columns here. So whenever I perform the syntaxes, my syntax is perfect, but I don't know whether this column is available on this table or not. This column is available on this table or not. This column is available on this table or not. Actually, this table is available on this database or not. We don't know, sir. Now, under the semantic checks, what it will do? It will verify this table is existing or not. This schema is existing or not. Okay, these columns are existing or not. Under the semantic checks, it will verify. 1 second. Okay, under the semantic checks, it will verify whether object is available or not, table is available or not, view means columns are available or not, means whatever your select statement, how complex select statement you've written, it will validate all the columns, tables, schemas, everything, whether it is existing or not. Where it will check? Under the semantic checks. Under the semantic checks, it will verify your objects, your columns, everything, your join conditions, everything, perfect or not. Once it complete the semantic checks, see, this is the high level language, sir, easily to understand. Subbu, I'm not mean to say I'm not understanding. Will you give some more example, better example to understand? For example, to show you that, sir. Okay. See, I am just, you won't do all this stuff in the real world, but just understand, sir. What do you mean by syntax checks? See, in this table, there is no column called test. Okay. Test. There is no column called text. See, if I show you, okay, sp underscore help. Okay. When I execute, see these many columns are available in this table. Okay, these many columns are available, but there is no column called test. Nowhere you will find test. See now, but when you run the syntax checks, there is no issue with that syntax. There is no issue with the syntax. What is the problem here? Semantic checks only. Okay, there is a problem with the semantic checks. Under the semantic text only, it will open. So how to perform the semantic checks externally, Subbu? Okay, this is See, internally, these are all doing. You no need to do all this stuff. Internally, it is doing. But externally, if I want to do show you, let's do one thing. There is one more set operator called FMT only. Okay, format only, format only, format only. See here, parse only means it will just check the syntax checks. When you enable parse only, it won't run the query. You won't get any results. Nothing it is doing. It is just checking the syntax. But here, it is checking the semantic. When you go for format only, it is checking the semantic check. So let's change the database name, sir. Okay. Now when you run this query, now see invalid object name. See same query if I written here. My parser doesn't show any error because it is just checking the syntax. Your syntax is fine. Means your select statement, your from class, your table names, your syntaxes don't have any mistake. So your parser is shown success. But under the semantic only, what it will do, it will try to get the information like, okay, this table is available or not. Okay, these columns are available or not. So for example, let's write this one. Okay. Okay, instead of that, what I can do, let's copy this one, sir, but better understand. Okay. Okay. Sorry, sir. My baby is calling me. Okay, right, see. Now, here, there is issue with the table. This table is not available in this database, sir. This table is not available. Test table is not available. Here, column is not available. See, when I run this query, it will show you column is invalid. When I run here, object is invalid. Now, this is what semantic checks. I hope you understand what you mean by semantic check, what do you mean by syntax check? Everyone? So, command parser will check the syntax checks. Once your syntax is fine, it will check the semantic check. Once the semantic check is also fine, 1 second. Okay, see, once it completely checked the semantic, syntactic, and semantic, everything is perfect. Now, next is it will prepare the query tree. Internally, see, this is all internal, sir. Okay, being you are learning, sometimes first time you are learning, right? That is the reason I'm showing practical demo so that you will keep on your mind instead of remembering all this theoretical. It's okay, sir, but when I show you little practical, you can store in your brain easily. Okay, command parser, first it is checking syntax, next it is checking semantic. What do you mean by semantic? Whether table is available, columns are available, whatever you are writing, all are existing on the database or not. So first it will validate syntaxics, semantic. Once everything is perfect, then what it will do? It will prepare the query tree. What it will do, sir? It will prepare the query tree. Internally, it is preparing the query tree. Okay, see, this is how it will prepare the query tree. Internally, it is preparing the query tree. Once syntax checks, once semantic checks, then next it will prepare the query tree internally. Okay, why Subbu it is preparing query tree means this select statement is high level where you can understand, but SQL can't understand this one, sir. So SQL is converting high level language to low level language where SQL can understand. All the programmatic languages, including Java, C, C++, all the languages, whatever you are seeing, that is a high level language. You can understand, sir. That can't understand by your engines. Definitely they need to convert into the missile level language. That is nothing but low level language where engine can understand. So that is getting by the query tree. So now query tree means it is converting high level language to low level language where SQL can understand. Now what in the query tree it is doing? Oh, it is a select statement. First it is getting the table. See, it is getting the table. What table is getting? Sales order details it is getting. Okay. First it is getting the tables. Under this table it is getting all the columns, required columns. Okay. All the columns it is getting, because whatever the columns you are mentioning, okay, sales details, carrier tracker number, okay, it is getting the sales details column and the carrier number column. Okay. It is getting sales details and it is getting carrier column. Now it is preparing based on your query. It will start preparing the query tree. Okay, it will start preparing the query tree. There is a dedicated session, sir. I will here. Okay, I will show you this one little deeply in the advanced level, because sometimes your performance will impact here only, not at the runtime. While it is parsing, while it is checking the semantic, while it is preparing the execution plan itself will take a lot of time. Okay, so to understand this one, I will take a separate session, sir. This one, as of now, try to understand. Once the syntax checks is done, once the semantic checks is done, it will prepare the query tree. It will prepare the query tree. Is it clear, everyone? No, yes. See, that concept we are calling. See, once parsing is done, okay, once parse is done, then it will prepare the algebra. Means it is preparing the query tree. It is binding everything and it is preparing the query tree. Once your query tree is prepared, okay, that query tree is going to the optimizer. That query tree is going for the optimizer. Optimizer is the backbone for entire your database engine, sir. Entire your database engine, optimizer will plays a major role. I can't discuss within 5 minutes. Okay, now we are discussing just 5 minutes. Now it's very tough to understand optimizer. Optimizer itself, I will take a separate session, sir. Okay, that's the reason I am telling that each and every component throughout our training, you will get it. As of now, just understand only bare minimum things. You will keep on our journey multiple times. I will get back to these all concepts in different situations so that you will become strong. As of now, I am discussing only 2 to 3 minutes for the optimizer, but I will take a dedicated session for the optimizer. So once your query tree is prepared, that query tree will go to the optimizer. Optimizer prepare the execution plan. What optimizer is doing? Optimizer will prepare the execution plan based on the query tree. Whatever query tree, right? Based on this query tree, optimizer will prepare the execution plan. See, this is how your execution plan. It prepared one execution plan. Okay, based on your join conditions. So, for example, if you are using order by line total descending, for example. So, see, now currently you are having only 2 operators. Now I added one more class called order by class. When you run execution plan, see, now entire your execution plan is changed. See, I hope everyone noticing. Entire your execution plan has been changed. Just before let me do one thing. Let me run 2 different statements. Okay, to understand. You think that, okay, I just added one order by class Subbu. Okay, whatever the data I retrieved, I am ordering with the line total column. Just that is only I'm doing, apart from nothing else. But see, entire your execution plan has been changed. For first query, only 2 operators. One is a select statement, one is a cluster index seek. For second query, you are seeing the parallelism, you are seeing the sort operator, you are seeing the compute scalar, you are seeing the cluster index scan, cluster index seek. So entire your execution plan has been changed. And also you are able to see the missing index also. And the cost of this query is only 13%, but cost of this query is almost 89%. The cost is also increased, and the execution plan has been changed, and you are getting the missing index also. See, based on your query, your optimizer is preparing the execution plan. How your optimizer is preparing the execution plan? Based on your query tree. Query tree. What is that query tree? Is a low-level language where SQL can understand. Okay. Once your parser is done, once your syntax X is done, once your semantics X is done, then your optimizer will start preparing the query tree for your query. Once the query is prepared, query tree is prepared, that query tree will go to the optimizer. Your optimizer will start preparing the execution plan based on the query tree. Query tree. Based on your query tree, your optimizer is preparing the execution plan. Okay, Subbu, fine, it is preparing the execution plan. The input is query tree. The input for optimizer, the input is query tree. For optimizer, the input is query tree. But based on that query tree, how optimizer is preparing the execution plan, simply it can't prepare, right? Okay. So optimizer is a cost based and selectivity based. So please remember these two terminologies. Very, 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 very important. Your optimizer will prepare the execution plan based on the cost base. Okay, so how it is preparing the execution plan? One is cost based, one is a selectivity based. What do you mean by cost? See, imagine your family decide that your family wants to plan a trip. Okay, what is the first thing you will see? How many people, right? Nothing but selectivity. How many people you are gathering for this trip? That is the selectivity first. Once your selectivity is confirmed, then you will see the budget, right? Of course, how many days, all the stuff, leave it, sir. Budget is very important, correct? So like same, query optimizer is also preparing the execution plan based on the selectivity, means how much data we are trying to retrieve, how much data we are trying to process, how much data you are processing, how much data you are retrieving. That is nothing but selectivity. One more is a cost base also. So how many operators you are able to see based on your query, and what is the cost of index cluster index seek is only 15% cost. Compute scalar 0% cost. Here also 0%. But sort operator is the highest consumer here. There is a 70% is a cost. Out of 87, 70% the cost is a sort operator. Sort is a very expensive operation now. And the parallelism it is going. Under the parallelism is a gather stream again. So you will see a lot of stuffs are here. Okay. So as of now, only remember 2 points, sir. What is the 2 points? Optimizer is preparing the execution plan based on the query tree. Once your query tree came, using that query tree, your optimizer is preparing the execution plan. While it is preparing the execution plan, your optimizer mainly consider two things. One is the selectivity, one is the cost. Always optimizer will choose the least cost execution plan only. Always your optimizer will choose the least cost of execution plan only. Always. So once your execution plan is prepared, then that execution plan will go to the executor. That execution plan will go to the executor. Now executor will start the executing that plan. Is it clear? Not clear, everyone?
Clear.
So what is the first point I told? Once it enter into the database engine, first it will go to the relational engine. Under the relational engine, first it will go to the command parser. It will first check the syntax checks. Then it will do the semantic checks. Then it will bind the request and prepare the query tree. That query tree will go to the optimizer. Optimizer will prepare the execution plan based on the selectivity, based on the cost. It will prepare the execution plan. Once the execution plan is prepared, then it will go for the executor. Now executor will execute the request. Got it? There is no data here in the relational engine. There is no data. Okay, not okay, everyone. Clear, not clear?
Clear, sir.
Clear.
Okay. Yeah, that's it, sir, for today. Tomorrow I will continue rest. Okay.
Okay, sir.
I will share one document mostly today or tomorrow. Whatever I'm explaining, everything will be there. You can just refer that small document to simplify, sir. Again, I am showing everything practical only. If you try to explain like how I am showing practical to the interviewer, definitely they will impress, sir. That is the reason I'm showing practically one by one. Okay. So theoretical is a lot, sir. It's tough to remember the sentence, everything. Explain what I am displaying to you. That is easy. If someone asking, will you explain SQL Server architecture means? Okay. SQL Server engine contains the 3 different layers. One is a protocol layer, one is a engine layer, one is a SQL OS layer. First, a protocol layer will establish the connectivity using the network protocols like a shared memory, TCP/IP, and named pipes. Okay. Using the network packets, it is enabling the connectivity. Once it enables the connectivity, first it will go to the database engine. Under the database engine, first it will go to the relational engine. Under the relational engine, we are having 3 different components: command parser, query optimizer, query executor. Command parser, first it will check the syntax checks. Next, it will check the semantic checks. Under the semantic checks, it will validate whether table is existing or not, columns are existing or not, data type is mismatching or not. Everything it will check. Once everything is done, then it will bind the request and prepare the query tree. Nothing but high level to low level it is converting. Once it will prepare the query tree, that query tree will pass input for the optimizer. Optimizer will prepare the execution plan based on the selectivity, based on the cost. So once the execution plan is prepared, then your optimizer, next it will go to the executor. Executor will run the execution plan. So, but in the relational engine, there is no data. That is how you need to explain to the interviewers. I can't write all this stuff in the paragraph level, okay? So try to understand what I present you. Then that will make easy to explain, okay? But I will share one document, a simple document, okay? Which I personally prepared, okay, to simplify. Because these concepts are little clumsy concepts, okay? More theoretical. Some people will love theoretical, some people will, Subbu, no, no theoretical. So we'll find 2 kinds of mindset people, right? I will share one document to you, okay?
Okay.
Yeah, thank you, sir.
Sure, sir.
Yeah, see you tomorrow.
Thank you.
Thank you.